Hello viewers, in today's class we are going to take up one problem related to independent events in probability. The problem goes like this. The probabilities of A, B, C solving a question are 1 by 3, 2 by 7 and 3 by 8 respectively. Now we have to find the probability that exactly one of them will solve it. So the problem here says that suppose we have three students A, B and C, right? A, B and C, and a problem is given to them to solve. Now this question says that the probability of solving the question by these three students is given by 1 by 3, 2 by 7 and 3 by 8, right? So if we denote uh, the events A, B, C, event A denotes that the problem is solved by uh, the student A, and similarly B denotes the event that uh, the problem is solved by the student B, and similarly for C. So we have P of A, P of B and P of C. So the probabilities are given as 1 by 3, 2 by 7 and 3 by 8, right? Now we can find the probabilities that the problems will not be solved by these three students. So we can write P A bar or A complement, right? So P A complement denotes that the probability that A will not solve the problem. So this is given by 1 minus P of A. Similarly, P of B complement is equal to 1 minus P of B, and P of C complement is given by 1 minus P of C. So this is 1 minus P of A is 1 by 3. Here we have 1 minus 2 by 7, and here we have 1 minus 3 by 8. So 1 minus 1 by 3 is 2 by 3. This is 7 minus 2, 5 by 7, and this is 8 minus 3, 5 by 8, right? So these probabilities are given, and we have evaluated the probability of not solving the problem by these three students, that is 2 by 3, 5 by 7 and 5 by 8. Okay, so now we have to find the probability that exactly one of them will solve the problem, right? So the problem is given to these three students and they are trying to solve the problem, and we have to find that exactly one of them will solve it. So what does it mean? It means that A will solve the problem but B and C will not solve the problem, right? So exactly means that A will solve but B and C will not solve the problem. So in case of not solving the problem, we write the complement. So here we have B complement and C complement. So this is the first situation. The second situation is that only B solves the problem but A and C does not solve the problem. So here we'll write A complement and C complement. Similarly, in the third case, the student C is able to solve the problem, but A and B are not able to solve the problem. So these are the three cases when exactly one student solves the problem. One student solves the problem. Right. Okay. So now we have to express these situations in terms of probability notation. So now this situation, the first situation is represented as uh, finding the probability of A intersection B complement intersection C complement, right? Similarly, the second condition is the probability of finding out the event A complement intersection B intersection C complement, and the third situation is probability of finding out the event A complement intersection B complement intersection C, right? So here we have to find the probability that exactly one of them will solve the problem. So we have to sum the probability of these three situations, right? So it means we have to find that the problem will be solved by exactly one student is given by the sum of these three probabilities, that is probability of A intersection B complement intersection C, then P of A complement intersection B intersection C complement, and then we have A complement intersection B complement intersection C, right? Okay, so now let us see how we can find these three probabilities, right? So here we'll use the concept of independent events. So what are independent events? So two events or two or more events are said to be independent events if the occurrence of one does not depend upon the occurrence of the other events, right? Or in other words, we can say that two events are said to be independent events if the probability of happening of one event does not affect the probability of happening of the other event, right? So in terms of probability notation, we can say that if E and F are two independent events, then the probability of E intersection F is given by PE multiplied PF. So this is the case for two events, and if we extend this concept to more than two events, then we can write P E intersection F intersection G is equal to PE times PF times P of G, right? So here we have the product of these three probabilities, right? So here we have three events, and we'll use this formula for evaluating these three probabilities. So using this formula, we can write this probability as PA times PB bar times P of C complement, and this can be written as P of A complement times PB times P of C complement plus P of A complement times P of B complement times P of C, right? Now viewers, here we must underline one important thing, that when E and F are independent events, then we have this rule, right? And when E, F and G are three independent events, we have this rule, right? So here the events A, B and C are independent events. Why? Because the probability of solving the question by one student is completely independent of the probability of solving the same question by the other student, right? So when A, B and C are independent events, then A, B complement and C complement are also independent events. Similar argument goes for A complement, B and C complement, and similarly A complement, B complement and C. So A, B complement, C complement are independent events. A complement, B and C complement are independent events. A complement, B complement and C are also independent events. So that's why we have used this result in these three expressions. Now let us substitute the values in this expression. So what is PA? So PA is 1 by 3. B complement is 5 by 7 and PC complement is 5 by 8. Then we have PA complement, which is 2 by 3, and B complement, sorry, it is B, PB is 2 by 7. Then we have C complement, that is 5 by 8, and here we have PA complement, that is 2 by 3, and PB complement is 5 by 7, and PC is 3 by 8, right? So now we can easily simplify this expression. So now multiplying these three quantities, similarly these three and similarly these three, we get 25 by 168, 20 over 168 plus 30 over 168. Now adding these three fractions, we get 50 and 75 over 168. Now expressing this fraction in lowest terms, we have 325, and here we have 3 5s are 15 and 1 3 6 are 18. So we have 25 over 56. So this is how we solve this problem, right? So the probability that exactly one of them will solve the problem is 25 over 56.